upgrade this 4 to 5. So that's why this, if greater than first max, then we do this. Else, if greater than second max, then also we change second max is equal to A of I. So making it 0 initially was the logic that first max would be A of 0. So definitely greater than 0, all the elements are positive. So in the first index, if it is greater than first max, then second max will become first max. Else, this condition will always be true in the first iteration because A of I will be greater than 0. So second max will get its value. So that's why 0 at the start. And after this O of n thing, we'll have our first max and second max. So we can write answer is equal to first max plus second max. And this has complexity O of n. So why did I discuss about this? You can see that brute force is O of n square. And there is another approach which is just O of n. So like brute force takes a lot of time. Okay, does anyone have doubt in this second sorting approach or that O of n approach? If you have doubt, then you can ask. I don't think anyone has doubt. I think this was done in course as well, like CS course, but okay, so no doubt. So I'll move on. Okay, so now you can see that brute force is not the optimal one when you have some other approach, which is better. Okay, so this was the example for finding. This is another example that you have a number n and two integers a, b, and you have to figure out if you can write n is equal to x times a plus y times b, where x and y are non-negative integers. So this is the answer, but I won't show you now because there is a question on code forces similar to this. I'll explain this after I explain the slide. This is also another example for brute force. The question here is that we are at city A. We want to visit city B, C, D, and E exactly once and then come back to our city A. So this person has to do that. And what he wants is you to find out what is the minimum total airline price that he has to pay. So brute force approach, there are each city is connected with a plane, right? So our start will be A, end will be A, and in the middle there are four options. So 4 factorial because each city has a place as a flight in between. So 4 factorial, so total 24. 24 pairs are there, and the 12 will be the mirror image of this 12. So like we just have to check for all this 12 which has the minimum price. So if you see this AB 185 plus BC 121, CD 174, 199, 133. If you add this, it's 800. This is second arrangement, third arrangement, fourth. You check all 12 and you find which is the minimum. So 676 is the minimum. First go to D, then to C, then to B, then to C, then to E and A. So this is also brute forcing. We checked all the possible and found out which is maximum. Okay. Yeah. So will brute force work in every problem? If it works, then like we are very happy. No need to think. Just implement what they said. So obviously it doesn't work in every problem because we know that computer can do 10 raised to 8 basic operation in 1 second. So we have to check what are the constraints in question. Like there are some test cases t. What's the limit of t? What's the limit of n? Before applying brute force, else it will give time limit exceeded. Like in the previous example, if n was 10 raised to greater than 10 raised to 4, then brute force wouldn't have worked. It would be 10 raised to 8, so it will give time limit exceeded. But there are better approaches. Sorting would work, and log n, even better, of n. So before applying brute force to a question, you must check if brute force will work or not. To check it, you just find time complexity of brute force approach and then put n inside this. So n square. Here it's n squared, so 10 raised to 4 square would be 10 raised to 8. So if it's greater than 10 raised to 4, this will be greater than 10 raised to 8 and it won't work. So basically before applying brute force, please check, otherwise it will give time limit exceeded. Okay, so this was about brute force theory, that basically you have to applying brute force is simple, just check all the possible cases, and whenever you apply brute force, just make sure that it will not give time limit exceeded. So any doubts in the what is brute force and why do we use it? The reason why do we use it is simple, because it's just simple. That's the reason. We don't have to think much, just check all the cases. So if it works, then why not use it? Why think much? Okay, so any doubts? I don't think so. Okay, if no doubts, then I'll move to problem part. Okay, so this is one of the problems that you already have done in if else set. I'm just showing you to see that this was the brute force. So it's a lucky division. Let me just maximize a bit. Yeah. Petia loves lucky numbers, and everybody knows that lucky numbers are positive integers whose decimal representation contains lucky digit 4 and 7. So 4, 7, 7, 4, 4, 4, 5 and 7 is not. This is not. And Petia calls a number almost lucky if it could be evenly divided by some lucky number. Okay, so we have a number n. If any lucky number divides this number n, then we are done. It's almost lucky. And we have to just check if a number is almost lucky. Yeah. So if you remember, what we did in the solution was we checked for 4 because 4 is a lucky number. So we first take input n. We check if 4 divides n, 7 divides n, 44, 47, 74, 77, 44, 4. So these are all the lucky numbers that we can make from 1 to 1000 because they gave limit, n is less than 1000. So this is brute forcing. We checked for all the lucky numbers from 0 to 1000 without thinking much. Like just check it. If it's correct, we see out here, else we see out no. And it clearly works here as limit of n is 1000, so numbers are not much. So it will obviously not give time limit exceeded. You can even remove, like this 44 is not necessary because if 44 divides then 4 divides, but no need to think that much as well. Just do brute force. Do everything that is possible and just see out, yes, if it's. So this is the example you already done, simple brute forcing. Now to the problem. Yeah, so the problem that I said, n is equal to xa plus yb. This is advanced version of this. Let's read the question. Polycarpus has a ribbon, its length is n. He wants to cut the ribbon in a way that fulfills the following two conditions. After cutting each ribbon, the length should be A, B, or C, and the number of ribbon pieces should be maximum. And we have to help Polycarpus find the number of required. Okay, so what the problem is, yeah, so the problem is that we have a ribbon, it is some length n. We have to cut it into some small chunks. The length of the chunk can be A, B, or C. But we have to cut in such a way that the number of chunks that are there should be maximized. So if you can see, this problem is similar to that. N is equal to XA plus YB plus ZC. This is simple, right? Because we have to cut, and the condition is X plus Y plus Z should be maximized. Okay, so any doubt in understanding problem statement? Should not be, because statement is clear. Okay, so let's start from the basic version. Let's remove first Z, C, and Z, the problem that was in the slide. So n is equal to XA. plus YB. Now we have N, we have A, we have B, and we have to find if X and Y exist such that this condition is met and they are non-negative integers. So 0, 1, 2, 3, and it works. Okay, so this is the problem. And like, can anyone think of a brute force approach to solve this problem? You have A, B, and you want to find X and Y such that N is equal to XA plus YB. Okay. Can anyone think of a brute force approach? Brute force means just remember checking all the possible combinations. So anyone? Okay, Hemant is there. Anyone else? Okay, let's give some time because the problem is clear, right? N is equal to X Y B. You have to find X and Y such that this condition is met. If you think of a brute force way, I think you should be able to find. Okay, Kaushik, go ahead.
Yeah, so am I audible?
Yeah, you're audible.
Yeah, so we can vary x, we can take the upper limit of x to be n by a and y to
Yep,
be n by b. We can run
yep,
two loops and then we can check for each and every x for each and every y.
yep, correct. So what it is uh, we know that x will be from 0 to n by a, right? Because if x is greater than n by a, then there's no meaning. The x times a terms will only be greater than n. And the y is 0 to n by b. Because if y is greater than n by b, then this term will be greater than n. So then also no meaning to check. So like this is the thing which I meant by that you have to vary a variable from lower limit to maximum limit. And the trick is just finding lower limit and max limit. So here it is n by a, n by b. So in this problem, what will we do is we'll first take n, a, b, n, a, b, and what I'll say is I'll say my flag is equal to 0. If flag is turns to 1 some way, then I know that I answer. So I'll make int a, int x go to 0 to n by a. Less than equal to, not less than, because it's possible that 1 of x and y and 0 and all the possible are there. And x plus plus, and I do same with y. So y will go from 0 to n by b. Again, you have to use equal to, else it will miss some solutions. And if n is equal to, what is our condition? X times a plus y times b. That's what we are looking for. If n is equal to x times a plus y times b, then I'll make flag is equal to 1 and I'll break. So this is the code for finding if solution exists for n is equal to xa plus yb. We simply brute force through all the possible x, all the possible y, and check if it exists. And now if you want to find the like maximize x plus y in this case, then again rather than doing this flag, you make a variable uns starting 0, and when you find, you make uns is equal to max of uns comma x plus y, right? Because we have to maximize x plus y, and we remove this break thing, this flag thing. Answer is equal to 0. It means that we didn't find any x plus yb. So it's correct, right? Answer should be 0. We didn't find. And if answer is something, which means that we found a x and y such that n was xa plus yb. So this is the solution for 2 ribbon. The 2 A and B thing, not C. And but the thing is, we can, like the previous solution, we can even improve this a bit. So anyone can see improvement. What was in the chat? Yep, x goes from 0 to n. Yeah, that was correct. Now, this was the brute force approach. As I told, brute force is not really efficient algorithm. So this is running in 2 loops, but we can do something better. Okay, Hemant is there. Anyone else? Just think, you should be able to, like think what's redundant here. Like we can easily check something in one loop only. We don't need 2 loops. Okay, I see no one. Yeah, go ahead, Hemant.
Instead of taking second loop, we can write y is equal to n minus xa by b.
Yeah, that's kind of correct. Okay, so what Hemant means is n is equal to xa plus yb. Let's remove this 3 part first. N is equal to xa plus yb. So what if I try to find y from this equation? Y is n minus xa by b, right? And we want y to be integer. So the thing we just have to check is n minus xa mod b should be 0. If this condition is met, then it means y is integer. So like just finding x gives you y as well, because they are connected by this relation. You don't need to run a separate loop for y as well. Just finding x will give you y. So to implement this would be we remove this loop. Again, x goes from 0 to n by a only. X has no value higher than n by a or less than 0. So now we check here only. The condition is that n minus xa mod b should be 0. Because n minus xa by b should be integer. Whenever it is integer, we have a solution. If n minus x times a mod b equal to 0, then it means that we have a solution. And what's the value of the solution? X is obviously x. And what's the y? Y is n minus x times a, not 1, by b. This is y because we solved this equation, n minus xa by b. This is the value of y which we get. And I can write answer is equal to max of answer, comma, again same thing. So this saves you a whole for loop. So time complexity goes like n square to n. So always when you use brute force, there is some improvement. Like most of the time, there is some improvement that you can make, which will make your solution, more time efficient. So just changing the inner loop to this would make our solution of n by a. And even again, like if you can check which is greater, a or b. So if whichever is greater, you put that here. So this becomes even lower. But the main point was that we can transfer from n square brute force to just n when you think something deep and do like this. Okay, any doubt in what I did, like how I changed it from O of n square to O of n? Chat. Okay, so no doubt in this one, right? You just find expression of y, and for each x you check the expression. Okay, Hemant has doubt, or that was you forgot to lower your hand? Okay, Salim has doubt. Yeah, go ahead.
Excuse me, in the code, shouldn't you write n minus x by b?
Here? Here?
Yeah.
Do you mean
Okay.
here? Okay,
Yes.
so
Yeah.
okay, so our what we want is n minus x a is equal to yb. So y is an integer, right? So n minus xa should be a multiple of b. Agree?
Yes, yes.
Okay. So if n minus xa is a multiple of b, then what's the condition to check? N minus xa mod b is equal to 0.
Yeah, got it.
You get it? We are not calculating y here. We are just checking if y is integer or not. If this was something else, let's say b minus 1, then y won't be integer. So it's not our solution. So we are just checking in this part if y is integer. If y is integer, then we add it here. This is where y comes, n minus xa by b. Clear or still doubt?
Yeah, yes.
Okay. Okay, any more doubts? No, I guess. Chat, no. Okay, then let's go to the higher version when there is C as well. So now we get to the real problem that n is xa plus yb plus zc. Okay, now again, brute force approach. What would it be? Now you all should get it because like we did lowercase. So what will be brute force approach in this one? Anyone? In case of three things, n is equal to xa plus yb plus zc, you have to find x, y, z such that all three are integers. Okay, yeah, that's correct, Narsimha. Bharat also, Hemant would also have same answer, I guess, 3 loops. Yep. So
We can do that in 2 loops, no?
yeah, we can do, but I'm asking for brute force approach. First brute force, then we'll improve. Yeah, that's correct, will be. Okay. So first let's go to brute force thing. As well. Then x limit will again be from 0 to n by a, and the reason is simple. Less than 0 is not possible, greater than n by will increase n, so no point in checking. Y's limit similarly n by b. Z's limit similarly will go from c by n by c and z plus plus, and we'll check if n is equal to x times a plus y times b plus z times c. If it is, then again we make answer is equal to max of answer comma x plus. Yeah. So again, Bharat already pointed out we can remove one of the loops, and the process will be similar to this 2 1. What will we do is we'll say zc is n minus xa minus yb. This is equal to zc. So again, if this thing is a multiple of c, then only z can be integer. So I'll remove this loop, make it come back, and I'll check if n minus xa minus yb, this was our expression for z times c. So if this expression multiple of c, this n minus xa minus yb is a multiple of c, then we have our answer, and answer will be x plus y plus, again we have the value of z already. The value of z is this by c. So again you can remove one loop from just brute force, like, so always try to find like just brute force gives again 3 loops of n by n by n by c, and this removes n by c element totally, so it is better than normal brute force. I think this will be clear as we did previous example. Any doubts still? No doubts. So it was simple, just as before, rather than 2 loops. And the special thing code forces did is it's 4000. So if you didn't remove this loop, the 4000 cube is 64, 10 to the 9, right? This won't pass. So the code force made sure that you do this improvement in normal brute force. So if you do this, then it should pass. Is there a test case? Nope. Let's just copy. Done it. Okay, printed. I forgot to print the answer. Out answer. Okay, now this should be fine. 2, I guess 2 was the right answer. Here as well, 2. Yep, seems to be working. Just make sure by submitting. Why wrong answer? What happened? 1 1 1 1. Okay, no, that's not the right. Okay, it gave wrong answer in this one. So what changed? Okay, what went wrong? Output is 4666 and answer is 4000. So all one. At all one case should be included in our solution because we took x to go from n by a. So it should be in our case, but somehow it's not considering it. Okay. Let's just see. 8, 1, 2, 3. Now it's giving 4. Just in that case, it has some problem. What? In 4000, it's giving 4666, else it's correct. Oh, we have to make sure this is greater than 0, right? Yeah, I think that's it. So we are removing xa and yb, but like this thing should be also greater than 0, right? Because c should be greater than 0. That thing I missed first. So this should be greater 0. I think now it should be fine. Okay, now it's missing by 2, equal to 0. I'm missing so many corner cases. Yep. So what I missed was that like I forgot to make sure that this is greater than 0. Like you get it right? Why it should be greater than 0? Because it's the value of z and z can't be less than 0. So in the tools case as well, you'll have to write this condition as well. My bad, I forgot, but okay, now it is correct. So let's check again. Now it's asking for code. I don't remember code. 189. Okay, let's go here and then submit. Now it should be fine, I think. Yep. Okay. Okay, video lagging. Voice is clear or screen share is correct or just video? Okay, I connected from mobile, so voice is clear. Okay, then it's fine, I think. Time lag in screen or my video? If screen, then it's a problem. Let's see. Screen, okay. Let me close some things then. Lag is not needed. Both. Let me try connecting to Wi-Fi, but Wi-Fi is even worse. Is it too much problem or I think it's fine, workable? It's fine, I guess. Okay then. Okay, let me close this as well. I don't need this. So maybe link to a bit. Okay, this is the last one that I'm gonna do. Flipping game. Lahoob got bored, so he invented a game to be played on paper. He writes an integers a1, a2, an, and each is either 0 or 1. And he's allowed to do exactly one move. What's that move? In that move, he chooses two indices I and j and flips all values ak for which their position are in range I comma j and flip the value. Okay. So what it's saying is he has a array of some 0, 1, 0, 0, anything. And he chooses two index. And does he flip both included? Yes, I and j is included. So he flips all these three. So 1 becomes 0, this 1 becomes 0, this 0 becomes 1. So this is flipping mechanism. Choose to index ij, flip all between ij. And he can do this only once. Exactly once. So he has to make a move even if it's losing something. Write a program to solve the little game of love. Okay, yeah, we have to maximize the number of ones after flipping. The number of ones after flipping. So in this case, we should flip this two or this two, which will give our two additional ones. We can do only one of them because we can't do both. So in this case, answer will be 1, 2, 3, 4, 5. Okay, now can anyone think of a brute force approach for this one? Like thinking brute force shouldn't be too hard. Just like, okay, I don't think I should give one more hint. If many people can't figure out, then I'll give. The problem statement is you have an array of 0, 1. You choose two indexes. You flip all the numbers in that index and you count number of ones. You have to choose indexes such a way that final count number of ones is max. That's the problem, basically. Any brute forcers? Nope. Okay. Let me give you a hint. Both indexes are limited in a range. So like there is a lower bound, there is a upper bound. Now it should be clear, I guess, because like as I explained, brute force is changing one index, one variable from minimum to maximum. So like in case of here, let's say I give two indexes I and j. So I is the starting index, j is the ending index. Now can you see any upper bound, lower bound for ij? Starting index, ending index. Okay. Problem is clear or not? What we have to do is, if it's clear, then like I is the starting index and j is the ending index. So there's some condition on I, some condition on j. Okay, let me give you I. I goes from 0 to n minus 1. But there is something I think. Count the number of ones, find subsequences more different between the number of zeros and a difference to. Yeah, but like I'm asking for brute force, like how will you implement the brute force approach? Okay. So I gave the limit of I starting index to 0 to n minus 1. Now can you give limit of j? J is the ending index and we are flipping from I to j.
1 to n.
No, in terms of I, it will be in terms of I, right? Because ending index can't be smaller than starting index. kind of correct, but
So we use I plus 1.
yep, I plus 1.
2n.
Yep. Like it will be less than n only n minus 1 because our indexing is that way. So what this does is, what I'm doing is, I'm choosing two index I and j, and I'll flip all between I and j. So it's kind of the similar problem as finding the max sum. What did you do in finding the max sum? What we did is we changed I from 0 to n minus 1. We changed j from I plus 1 to n minus 1. So again, same thing. We just find two pairs and we flip everything in between. This is the brute forcing, right? Like check all the possible combination. These are all the possible combinations. That's why I did that problem, so that you can realize that we have to find one index and another index and flip everything in between. There is something in chat. Storing number of wanted ranges. Yeah, you can do that as well, but I just want simple brute force. So simple brute force is this. Something else was why. Okay. Yeah, that's correct, but what is brute force? Okay, let me check input and AI. Let me write code, then I'll explain. It will be better, I think. Okay. So I have taken all the input. Now what I want to find is the I'll flip all the possible cases, and all the possible cases are choosing I first, choosing J, and flipping all between J. So what I'll do is I'll brute force through all the possible flipping cases that are there. So the possible case for that is I is equal to 0 to I less than n minus 1 first, and for J is equal to, okay, another thing. In this case, J won't go from I plus n because we can only choose one index, right? Like I choose just one, so 1 will flip to 0. So in this case, the indexes from I, comma j inclusive are being changed, and I and j are same if I'm changing just one element. So j will not go from I plus 1. I think Hemant was trying to say to I plus 1 to n, then it was correct, but I'm including, so I to n minus 1. Okay. Any doubt in why it starts from I? Because we have to check, we have to take single element case as well. So single element case, so I'll start j from I to n minus 1. Okay, so now I fix two things, I starting and j ending. So these are my starting and ending index. Now what I have to do is I have to count, if I flip this index, then what will be the number of ones, right? Because our main goal is maximum number of ones. So what I'll do is, when I have index I and j, I'll count how many zeros are there between I and j and how many ones are there. Let's say there are C0 and C1. C0 zeros and C1 ones between I index and j index, including I and j as well. So if I flip this, what will be number of ones in the final? In just this segment, it will be C1 ones. No, C0 ones. Because all this 0 would be flipped to 1. And what will be the total one in whole array? So for that, I need another thing, total number of ones. If I have total number of ones, then what can I do is, after flipping this, my number of 1 decreased by C1, all this C1 turned to 0. and increase by C0. All this C0 turn to 1. So this is my final number of 1. Okay, any doubt in this? How I found final number of 1s? I have total number of 1 in whole array. I found it already. And now in I to j, I count C0 zeros, C1 ones. So after flipping, this C1 ones will become C0, will become zeros. So my total one will decrease by C1, and all these C0 zeros will convert into ones. So my total one will increase by C0. Okay, any doubt in this? How do I find the number of ones after flipping? Okay, so find C0, C1. What I'll do is I'll make C0, 0, C1, 0. I'll iterate k is equal to I to k less than equal to j. That's what I meant because I'm giving equal to here. That's why j is I from n minus 1, I to n minus 1. Plus if I is equal to 0, then I increase C0. Else I increase C1. This is fine, right? Just counting 0, counting 1. But to find the answer, we also need total number of 1.
Hello?
Yeah, go ahead.
Yeah, instead of doing that, can we make if we are writing in the loop, can we make them minus
Yeah.
and count only
This-
once?
Yeah, we can do that as well. But this is just brute force. So I'm telling like common brute force. What do you do without thinking anything? Like there will be improvement as well. So to count the total number of ones, what will I do is I'll make a variable total 1 is equal to 0. And in this first for loop itself, okay, this is n. Why did I do this? The loop will go from 0 to n minus 1, right? So like I less than n. I was thinking equal to, but it's less than. So I less than n. And if a of I is equal to 1, then I increase total 1 by. So I don't have to write a separate for loop and checking number of ones. I can count number of ones as soon as I take input. I took input a of I and I check if it's 1. And after flipping I to j, what will be my number of ones? Total 1 minus C1 plus C0. So that is equal to max of answer. Okay, let me make the new variable. Int new 1 is equal to total 1 minus C1 plus C0. This is the new number of 1 in my array, and the answer will be answer comma new 1. So I have to initialize answer. Okay, this is also interesting. What should I initialize answer to? Okay, what should I initialize answer to? 0 or something else, or what do you think? Let me give you an example case. Let's say my array is 1 1 and is equal to 2. Or just 1. Like in all ones cases, any operation you make will decrease your answer, right? Like so initializing answer to total 1 is not good because the number of ones can decrease as well. We can kind of take for granted that we'll choose only that part which will increase the number of ones. But it's totally possible that there is no such part which will increase the number of ones. So that's why we should not initialize answer to total 1. What I would like to do is make it give some negative. This is never possible. So whenever, as soon as we find a part that will change, it will increase our answer as well. So answer will definitely turn to non-negative number in at least one iteration. So I choose just negative value here so that I don't have to you know, right here, if answer is equal to something, then change it. So total 1 won't work. If you write total 1, then it will fail in all 1's case. So this should be our answer. Let me just run it once. Yep, A of n. Okay, so did I give t as well? No, I am given t. So let's try 4 and all ones. Answer is 3. Why 3? Because we have to definitely convert 1 1. What if I have given answer is equal to total 1 here? Then 4 again 1 1 1 1. Answer will be 4. Because at the start of the loop, answer is 4 already, and every operation decreases answer. So answer will stay 4 and 4 because it is max here. So we should not give total 1. You should give something which you know that will definitely won't happen. And then okay, code is done. Let's just see. Okay, why is it giving 6? C1, C0 plus or C1 plus. Total 1. This is correct. And what's the issue? Okay, answer is 4, right? Okay, but my code is going 6. That's bad. J starts at I, J goes to N, you go till J, count 0, you count 1. Okay, there's something. This is also one of the silly mistakes that I tend to make. Can you see this is A of I? Like that's too bad. This should be okay. I'm iterating K. So these are, you are finding all the silly mistake that I can make. I think that would be pointing to mistake only. Yeah, okay, correct. So we are checking from k is equal to I to k is equal to less than equal to j, right? So we have to make a of k is equal to 0. Now it should be fine, I think. Yeah, now it will 4. Let's run another one just to check. Yeah, it's also getting 4. Seems correct to me. Does anyone have doubt in logic part, anything? Or can you find any one of my other sillies? I don't think any mistake is there now. Okay, any doubts in this one? Let's just submit it if no doubts. Thank you. 6, 8. Stuck at 8. Yeah, it's right. Okay, something is there. Okay, yeah, I can. Okay, so what I'm doing is I'm brute forcing through all the possible, all the possible pairs that I can flip. So let's say I'm flipping from, let's say I'm flipping from I to J. Then my I have possibility to go from 0 till n minus 1, and my J has possibility to go from I to n minus 1. This is starting index, this is ending index, and I'm flipping everything between I and J, including I and J. So these two follows are just finding I and J, which I'm flipping, and this third for loop is to count how many number of 0 and how many number of 1s are there between I and J. So starting at I, going to less than equal to J. If A of k is 0, then C0 increases and C1 increases. So this loop finds number of 0 and number of 1 between I and J, including I and J as well. And if I flip this part, what will be new one? New one will be total 1 minus C1 because all the C1 that were in this region will get converted to 0. But plus C0 as well because all the C0 that were in this region will be converted to 1. So my new number of 1 is total 1 minus C1 plus C0. And then I just make answer is equal to max of answer comma new 1. So for all the INJ, just brute force through all the possible combination and find the best suited. And best suited condition here is maximum number of 1s. Okay. Okay, so I think this was the brute force approach. Was it? You can kind of try to improve it a bit. Like this problem can be done in O of n square as well. This loop is really not needed, but I like you to try it because, as I explained in the previous loop, you can always almost always improve your brute force algorithm to some better algorithm. Why is answer initialized method? Okay, because the thing is, our answer is max of answer comma new 1, right? So I can initialize answer to 0 as well. But what I like to do is make answer as small so that uh, anything which comes in the new ones term will change my answer. So if I don't initialize answer, then I have to I have to find one answer first and then change it. So what I like to do is give it so negative value, like I can give minus 1000 as well, so that as soon as it finds a new one, the answer will change to that new one. So even if this new one, the new one will be 0, even if new one is 0, my answer will be changed to Z. That's why 0 is fine. I think you can initialize to 0 as well. This will also work, but what I like to do is keep it as minimum such that even if anything uh, possible comes into new one's term, it will change my answer to that. Just to take care of all the corners. 0 would work as well. I think 0 should work, but 1 won't work necessary. I can even show you one case where 1 will fail. 1 and 1. It's giving 1, but we have to flip this one to 0. So answer is 0 in this case, right? We have to flip this one. But if you initialize to 1, you will get 1. But 0 should work as well. Okay. Do you get why? Because anytime I encounter a new one, I just want my answer to change from negative. So 1 won't work, 0 will work. 0 will work as well. It will change the answer. Clear or? This max function will give max, right? So even if my new one is 0, new one is definitely not negative. Like that's not possible. So even if new one is 0, my answer will become that in the first iteration. That's why. Like 0 works fine. You can keep 0. Yeah, it's over. Like this was the final part. Okay. I got 9 minutes, but sorry for extending. It was because of that mistake. But okay, this is over. Now Ganesh can start. Thank you. Any doubts? Just before going in anything? No. Okay then. I'm stopping. And yeah, Ganesh, now you can go ahead.
So, am I visible and audible?
Yeah, you are visible and audible.
Yeah. So, I'll share my screen. Um, my screen is also visible, right? Is my screen visible?
Yes, Ganesh.
Okay, thank you. Okay, I'll start. So, so today I'll be saying about the specific approach called greedy approach. So it's a way of approach where you execute the step which gives the most immediate benefit. So at each part of the code, you should execute the step which will at that moment it should give you the most benefit. That uh, so so that task you will do. So that is this type of approach. But this approach need not always be optimal. There are cases where these approaches fail as well. So I'll show you where these cases fail. So so how to execute a greedy approach. So as I said earlier, we choose the task which will give the most immediate benefit for us. And we don't care about what will happen in the future and all. So at that moment, it should give us the benefit. If it gives us the benefit, then we can execute that task. And also, there is no backtracking in this approach. So once you execute a step, there is no going again backwards and seeing if it is correct or not. So once you execute a step and that's it. After that, there is no backtracking in the solution, like in this greedy approach. So I have an example here. So it's a pretty basic example. There are n items to be added in a box, and we have some items with us. What we need to do is we have to put these items in the box such that the value of the box is the largest possible. So the value of the box will be the sum of all the items in the box. So in this specific problem, the greedy approach would be to add the item with the largest value first to the box, and then add the next largest value, and then again add the next largest value, and keep going on until we until the capacity of the box is full. So that would be the greedy approach. So at each point of time, you are executing the task where the items value would be the largest possible, right? So here this approach would be very greedy approach. So I told you, right? This approach does not work. This approach does not work all the time. So for example, if you see here, so in this problem, our task is to navigate through this graph and then reach the end point. And when we go through this, we have to add all the elements that we go through. So our task is to maximize the sum of all those elements that we go. So if you execute a greedy approach, what we could do is, so first we have 7, and it will compare 3 and 12. And if you compare 3 and 12, then this would be the greater. So it will go to 12, and then after this, now it will check. Now it will compare 5 and 6. And if you compare 5 and 6, these two among these two, then this one will be the greater. The 6th one will be the greater. So it will go from 7 to 12 to 6. But actually, that is not the maximum thing that we are looking for. If you see here, if you go from 7 to 3 to 99, only then there will be only then there will be the maximum thing that we are looking for. So for example, if there had been so this 3 is connected to this 5 and 6, and this 12 is connected to this 99 and 8. If that had been the case, then our greedy algorithm would have worked. So it would go from 7 to 12, then immediately it will go from 12 to 99. If this 12 and this 99 and this 12 and 8 are connected, then our greedy algorithm would have worked. But in this case, it will not work. So in the upcoming slides, I have some example. So first is this knapsack problem. So what we have is we have n items, each having some specific weight and a value. And what we need to do is, and we have a sack or a box or anything can be like that. And we have to, so this sack has a maximum capacity of W. So up to only this W weight it can hold items. After that, it cannot hold any items. so we have to put items in the stack such that the total value of the stack is as large as possible. So and in this problem, um, like you can fill the items partly also, like you can break the item into two or any number of parts, and then also you can fill in the item. Like for example, so here if you break this 100,50 this item, so basically the first thing is the value, and the second thing is the weight of the item. So here if you break this into half, you'll have two items as so those two items each will have its value as 50 and its weight as 25. So so basically what I mean is you can add this fractional items also. It's not that you have to only add the full item. So so can anyone say like how to execute this as a greedy problem? I can raise your hands or put in the chat. So this is quite simple. You have to maximize the total value of the sack. Okay, yeah, I think so. Yeah. I'll give some. I'll give a minute. Can think on this question.
Hello.
Yeah.
We can use that. First of all, we divide all them into fractions of. I mean, we divide the value by weight and adding each gram having the highest value until we reach the maximum weight of the sack.
Yeah, correct. Yeah, that is a so that is the approach that we need to take. Yeah, yeah. In the chat also, Karthik and Prilly, you have written that that is the correct approach for this question. So I have the solution here. So yeah, so basically you have to divide this this value by the weight, and you have to like find out which has the largest that which has the the largest ratio of this value by weight. You have to check which one it is, and then you have to fill it accordingly, and then at last the last item you can fill it like in fractionally also. So that would be the approach for this question. So this is a greedy a pretty famous greedy problem, let's say. So I have some other problems as well from code forces. Yeah. So so here it is like this is also a pretty simple problem only. It's based on strings. So let's call let's call a string if and only if it consists only of two types of letters, A and B, and every two consecutive letters are distinct. For example, BA and AB, so ABA are good string. And here, this one is not a good string because it has like two consecutive B's. So this is not a good string. It's a bad string. So what they're saying is we have a number of strings, which is only the character A, and you have B number of strings, which is only the character B, and then we have C number of strings, which is the string AB. So what you have to do is we have to arrange the strings in some order. So you can put two ABs first, like AB, and you can form a string. So basically you have to like with all these strings, that is with all these A plus B plus C strings, what you have to do is you have to like merge them together, and then you can and then you have to find the string that matches this condition, this good condition, and then you have to obtain like which string will be the like the longest among these all these strings. So I'll give some time for getting this question because I think it's a new test. If you have the solution, you can like raise it or put in the chat. Can see the examples as well. So I'll say for one example, and then you can think on for the other example. I'll do for this for this. So there are two A's for us, one B for us, and two ABs for us. Okay. So what they have done is they had first put this two ABs here, and then they have put it as ABA here. So if you check this one, this is like this like satisfies these conditions, right? So this is a good string. So this length is 7. So we have to output the length of this. So if anyone has any idea how to approach this question, so this is also approached by this by the approach itself, by the greedy approach. Okay, yeah. Here's the
Yeah, hi, am I audible?
yeah. You can go ahead.
Yeah, so basically using the greedy approach, you can finish off with C because AB will alternate anyways. Then you can move on to the first two parts. If then you have to find the minimum of them. If minimum is B, then you can add an A at the end. So you'll have to add by 1. Otherwise, if minimum is A, then it's the minimum of it.
Yeah, that is the approach for this question. So if anyone else has any other approach, you can check it.
Hello.
Yeah.
Yeah, first of all, we will multiply the last C into 2 and add 2 for it.
Yeah.
If and only if A and B are greater than or equal to 1. And after that, we'll minus 1 from both A and B, and we'll take off the minimum of then A minus 1 and B minus 1 and add it to the previous 2 times C plus 2.
So, okay, so at the start itself, we are having the like the answer is 2 times C plus 2, and then And then what we're doing, I couldn't get.
Yeah, after 2 into C plus 2 plus A minus 1 plus B minus 1 actually. If we earn minimum of A minus 1 and B minus 1.
Okay, yeah, okay. Yeah. So that's also, yeah, both approaches are greedy approaches and both are quite similar. So I think you can go ahead and put this one. So I need A, B, and C. So and then I'm having answer. If so this was what I had thought of. So if A is greater than or equal to B plus 1 and should be added by 2 times is greater than or equal to A plus 1. Glad answer by 2 times A. This case would be both A and B are equal. So this first case it would be that so I think it would be better if I draw on the whiteboard. For example, let's say I have 3 ABs. And I have let's say 2, let's say 3 A's, 3 A's, and I have 2 B's. So now my final string will be, so as usual you can add these first 3 ABs at the first itself. So we are greedily adding these ABs at the first itself, and then we are going to add again greedily as this A and B separately. So these are 3 ABs, and now I'm going to add AB separately. So I'm going to add A, B. So now I have A and that's it. So if you see here, the, these A's are equal to B plus 1. So this is our maximum case. So if this A goes beyond B plus 1, so for example, if I have one more A, like if I have 4 A's, then I cannot add A here also. I cannot add A here also. So anyway, even if I have this 4 A's, our answer would be so this number of B's, right? So there are 2 B's, and for each B there is a A. So these 3 into 2. So this is for AB, and then for each B there is a A. So there will be 2 times B. So this would be times 2 in this case, times 2 plus at last I'm adding 1 A here plus 1. So even if I have extra characters like A greater than B plus 1, this extra A is of no use to me. So I cannot add it here also. I cannot add it here also. I cannot add it in between also. That would make the string bad. So what I had done is, if A is greater than or equal to B plus 1, so initially I had put as 2C, because for all cases it would be 2C. So at least there will be 2C like the string, 2C characters in the string. And then I had added 2 times B plus 1. I had added 2 times B plus 1. So basically 2 times. So this was our B. So 2 times B plus 1 I have added. Yeah, and then if the same case, if I invert this, so let's say I have 2 A's, I have 4 B's. So let me clear this. So if I have, so now same, I'll do the same thing. I'll do A, B, and then that's it. I can add only one more B here at the starting. So here also the extra 1B, it is of no use to me. So again I'm getting the same thing, but instead of B I'm getting it as A. So I'm getting this 2 times C plus 2 times A plus 1. So because this extra B will anyway be of no use to. So if this both conditions also are not possible, then the third condition is both are equal. If both are equal, then I can again readily add it as AB itself. So that would be 2 times C plus 2 times A or 2 times B. You can put it as you can have it as anything also, because both would be the same thing. So this was my approach to this problem. So what others said also were like quite similar to this approach only. So if you have any doubts on this approach, you can like, raise your hand or put in the chat box. I think there will be no doubts because it is quite simple. And it is also similar to what others. Let me for some cases. Yeah. Getting similar. Okay, I think there was. And this 2 times C plus 2 times minimum of A plus B, but minimum of A plus B. That approach, okay. 2 times minimum of A plus. I think so. If I have, so let's say I have 4 here. But this answer would give me yeah. What is it say? You have to add 1 also. If if A and B are unequal, you have to add 1 also. Yeah. Because if A and B are unequal, you can either add a A here. You can either add a A here, or you can add a B here. So you have to add 1 also. That will be the correct approach. Right? Yeah. Okay. Next. I think we can. So I think there are no doubts for this problem. I think you can go on to the next one. The next thing is an even simpler problem than this. So 4 segments. Monocar wants to draw 4 line segments on a sheet of paper. He wants the right segment to have its length equal to AI, where I is from 1 to 4. These segments can intersect with each other, and each segment should either be horizontal or vertical. So you can't have slanting lines. You should only have this horizontal or lines like this. So horizontal lines or vertical lines. So monocar wants to draw the segments in such a way that they enclose a rectangular space. So they have to make a rectangle like this, and this area of the rectangle should be as large as possible. If monocar wants to draw 4 segments with lengths, so they have given an example here. So I don't know if it's he or she. Anyway, so he drew it as, so there are 4 segments of line 1, 2, or 3, and 1, 2, 3, 4. Okay, so so we can say this is first line segment, or AB is the first line segment, and then CD, yeah, this is the line segment of length 2, and then this is a line segment of length 3, and then this EF is a line segment of length 4. So and this would be the largest possible rectangle, maximum possible area, the maximum possible area. So so that would be our answer. So our answer would be, if the 4 line segments are 1, 2, 3, and 4, our answer would be I think 3. Our answer would be 3. Yeah. So this is the problem. So this also you can solve using the greedy approach. I'll give a few minutes for like reading the problem. Oh, okay, that's good. These are just the input things. So here is the example for us. We have then the second test case as another example.
Hello.
Yeah.
You can just
Yeah.
sort. You can just sort the array and multiply with A0 and A2.
A2, yeah, correct approach. Second max into min. Yeah. Second max into second min. Yeah. That is the correct approach. So, does anyone have any doubt? This question. It's pretty like the solution would be like only for one line. So, if you have any question, you can raise your hand. I think it's pretty straightforward, I guess. Have to test it. Array size. Sample. Oh, sorry. Three 25, 3 and 3. So, 225, 3 and 2. Yeah. many numbers. Okay, I have already submitted this code, so I think I can show you the correct solution also. I've done the same thing. Here it is. Yeah, I have done the same thing, the exact same thing. So this is the second problem. So the first two problems were quite simple. Second one would be, I think, quite challenging, but I think you can do it. So histogram ugliness. So there is a histogram with n bars of height a1, a2 up to an for customers. Okay. However, the more he played with this new histogram, the more he realized its imperfections. So he wanted to modify it to his liking. And to modify the histogram, he's able to perform the following operation any number of times. So basically, you can select any index and then decrease its height by 1. And then what he does is he defines something called as an ugliness score, and it is the sum of the vertical length of its outline, the number of operations that he performed on it. So basically, if this is the histogram, so this is the histogram, then these are the outlines. These so these things marked in red is the outline. Yeah. So here this outlines length. So initially, if you don't do any operation on this histogram, then its ugliness would be this 4 plus 4 8 plus 1 9 plus 3 12 and plus 6 18. So this ugliness would be 18 if we does not modify the histogram at all. So for example, he takes this like the third thing and he reduces it by 1. Reduces operation. Yeah, you can apply the operation once on column 2 and twice on column 3. Okay, so first he is decreasing this one, and then he's decreasing this one twice. So this will reduce by 1. So from 8 it will go to 7, and this will reduce by 2. From 9 it will go to 7, and other things will be remain unchanged. So now if you see, yeah. So now if you see, the ugliness would be 4 plus 3 plus 1 plus 6, that is 14. And then he performed the operation like 3 times. So it would be 14 plus 3, which is 17. Why they have written dollars? Maybe I have written. It can be proven that this is optimal. So this would be the like the lowest ugliness that can be achieved. So what our task is, to find what is the like minimal ugliness that can be like achieved by performing any number of operations. So you are free to perform any number of operations. So you can also perform 0 operations. That's also possible. I think I mentioned here. After some number of operations, yeah, I can perform 0 operations also. So is the video lagging? Can anyone else confirm? It's lagging for everybody. Okay, so final data would be slower than this effect. So is it bearable or is it too too laggy? If it is too laggy, then I have to switch my connections. Okay, if it is fine, then so I think I'll explain once more. So basically, there is this histogram, and there is and the ugliness score is like you have to add all these borders, and then you can perform some operations. So the total ugliness score would be after like all the operations are performed. The final histogram, you have to count all the borders plus the number of operations you have made. So that would be the ugliness score of the final histogram. So what your task is to perform some operations on the given histogram. So they have given the heights of each thing. Like so in the first case it would be 4, 8, 9, and 6. So that's what they had given. They had given here 4, 8, 9, 6, and they had given the number of weeks. Our task is to minimize this ugliness score of the total history. So you have to remember that you have to add this number of operations also to the final ugliness. Okay. So if any of you have any doubts in the question, I can explain. Okay, that's already a solution. Thanks. If any element is strictly greater than both the adjacent elements, we reduce it to correct. Yeah, this is exactly the approach that I had. So this is the correct approach. So I think I can. So if anyone have any different approach, you can share it. Since I can go to the whiteboard and explain how this approach is done. I think there are no doubts in this approach. So once I'll explain how this approach is done, so that it can be clear for everybody. So basically, I have a histogram like this, and then let's mark it from 1, 2, 3, 4, 5, 6. Okay. And then first one is 2, next one should be 4. Next one can be 6. Next one can be 6. Next one can be 5. Basically, these are not counted because these are inside, and these horizontal things are also not counted. Only the vertical borders are counted. Then I have this is my histogram. This is histogram. So now, for each operation you done, so for each operation you do, so let's say your ugliness initially some value. For each operation you do, you increase your ugliness score by 1. So for example, if so let's say I decrease this element to this down element, this second floor, I'll mark this option. 3, let's say. So if I decrease the second element by 1, it would become 3. So now this would be my final border. So initially it was here. And now I went to here. So now here we have decreased this border by 1. So we'll add a -1 here, but we have also increased this border by 1. So basically our ugliness score has increased by 1 by doing this operation. So if you change this one also, it will be the same thing. So this border would have been decreased by 1, and this border has been increased by 1. If you change this fourth element, that is from 5 to 4. So again, by making a move, you increase your ugliness by 1, and you are decreasing your right border by 1. So I'll put -1, and you are increasing this border by 1, or +1. So totally, again my ugliness score is increasing. So the only way to not increase your ugliness score would be, so you either perform no operations, or if there is something like this, if you take the third element, then so you can call this element as a peak, because this element is it's like smaller than the element number 4, and it is larger than the element 2, and it's also larger than element 4. So it is so this third element, so it's denoted by A3, is greater than A, and A3 is also greater than A4. So if this element, if I decrease by 1, so now what I'm doing is my ugliness score was, so my ugliness was initially it was initially some value. Now I increase, so I add +1 because I'm doing an operation, and then I so these two borders also are now getting decreased by 1, and the other borders will not be affected. So these two borders also are decreasing by 1. So now I'm so in total I'm getting -1. That is, I'm making my ugliness as like smaller. I'm not making it larger than what it was initially. So, and also you should not decrease it beyond this element. So if you see among 2 and 4, 4 is the maximum element, right? So you should not decrease this third element below this fourth element. So A2 should not be less than, sorry, A3 should not be less than max of A2 and A4. You have to take care of this one also. So I should decrease this up to here, only up to here, because if I go beyond this, then what will happen is so if, for example, if I go up to here, like up to 4, then what would happen is I'll create another border here. I'll show you. So if I decrease this this to 4, then what I'm doing is, so initially it was here, so I'm decreasing this border by 2, and but I'm forming a new border here that is not like desirable for us. So we have to make sure that we only decrease it to up to here, from here, and we decreased it to here. So you have to so what you have to do is you have to find all possible peaks, and then you have to decrease it to the element nearest to it, such that this there will be 2 elements adjacent to it. You have to decrease it to the maximum element adjacent. That would be the like logic for this. So does anyone have doubt? Is there a +1 in minus case? Okay, that's because they are doing one operation, right? So for each operation you do, you have to add 1 to the ugliness score. That is also one of the conditions that I had said. For each operation too, it will cost you 1 ugliness score. You have to add ugliness score. Yeah, okay. So I think we can. I hope there is no doubts. If there is any doubt, then please raise your hand. There's no doubt. I can go ahead and go specifications and then number of elements array elements. Yeah. First I'll have it as 0. So now what I do is I'll iterate through the full array and then this. So what I'm going to do is first and the last elements to be 0, and in between I'll have the element. So why I'm doing this is so you have to also include the first element, right? So for the first element also you need to have some things. So let this be the histogram and then goes down and then something. Yeah, this should be fine. This is our histogram, and then we have to add this vertical, this vertical, and this vertical lines. So for the first element, there would not be, so if I only have n elements in my array, then for the first element, there will not be anything to compare with. So I can set, after this, I can have this is 0. We can set the first element of the array to be 0. And then from 1 to n, I set these things, and then after that, beyond that, I'm going to set this also as 0, because this last element also can be modified. So this last element also can be modified. If you look at this case, if you decrement let's say this is 1, this is 2. If you decrease this one, so according to our condition, here it is A1 is greater than, so and A0 is 0. This case, and A1 is 2, A3 is 1, let's say. So it is satisfying our initial condition, right? A1 should be A1, like the adjacent element should be greater. So A1 is greater than A0, that condition is satisfied, and A1 is also greater than A. A1 is also greater than. A1 is also greater than A2. So that's why I have put like zeros at the end, so that we can compare the first and last elements also. So there will be something for us to compare. So now I'm going to this. Ugliness. So initial ugliness would so again I'm going to set so now then it should be greater than A. Yeah, ugliness, right? Um, also going to set my average, which also decrease away by to maximum of A of I. Yeah. Let's see. Oops. So should iterate it from 2 to n minus 1. Should iterate from 2 to n minus 1. Why is that? Why is that getting? I think I'll give you. If you raise your hand, I'll give you the mic function that you can say why it should be. Now I think you can unmute yourself. So Nishant, are you able to unmute yourself?
Yeah. Else we won't be able to means get means we will get runtime errors because we are comparing array of I minus 1 also, na?
Yeah,
I minus
but
I 1 also.
okay, wait, did I write? Yeah, but so if I is 1, then if I check I minus 1, I'll check it with 0 because a of 0 is 0 only, right? So I have set it. So here I have set my a of
I say
0 to be
okay, okay. Yeah, okay,
and
sorry.
the end element also be 0. Yeah,
Yeah, yeah, sorry.
yeah, okay. Yeah, no problem. If anyone else has a doubt, you can say.
Yeah, I think we are just lacking out of time, so we can just.
Okay, yeah, that's it. We
Yeah,
should
yeah.
also there is one doubt. I'll let you. My program is over. There is one doubt. I'll clear that alone. We should add one to ugliness. Yeah, yeah. That would be taken care by this step itself because so I'm only decreasing my ugliness by sorry. Yeah, here it is. By the difference between a of I and a of I minus 1 and the difference between a of I and a of I plus 1. So if you look here, here, here. If you look here, so this one, if I decrease, I'm decreasing this by 2. Uh, yeah, I'm decreasing this by 2. So for each operation I do, so here the absolute value of this difference is 1 only, right? So for each operation I do, uh, I'm decreasing my this border length by 2 and I'm adding 1. So finally I'm decreasing 1 only. If you see this one, this would be this difference between 6 and 5. So that is the idea actually. Okay, yeah. That's the problem. So I think we can split problems and should compilation error. Okay, I think we can. I think there is a. I think we are running out of time. So this is the exact same code that I showed. I don't know why it's giving compilation error here. This is the exact same code I showed, but instead of ugliness, I put it as answer here. Yeah.
Have you defined cleanness? I'm not sure. Can you just go back to your code?
Yeah, I had sent
Try to compile here.
Okay, yeah.
Yeah.
I made a silly mistake. I made.
Just try to compile here once again.
Yeah. Okay.
Yeah, it should not be it. Before you. Yeah, here as well, I guess. Yeah. I think now it should be correct. Just try compiling it again.
Okay. It's a bracket.
Yeah. And a semicolon again. Basically, yeah, when we're presenting the solution to a lot of people, we make a lot of error.
Yeah.
You can try submitting it again.
I'll just run for one test case just to make
Yeah.
sure.
I can see that you're not very confident now.
Yeah. Little nervous. So, why is the keyboard not working?
You can just try it manually. Yeah.
Mm, I think it is correct. Let's let's not this.
It should not give compilation error now. Okay.
You is giving. I don't know what is this. Uh, okay.
I think we can share the code later on so they can try
Yeah,
to.
yeah. Yeah. Where
Okay, I think you missed the if brackets. There should be brackets with if, right? Like without that, it will do just the one next line, right? You want both the lines, okay. So again, these are a few errors which can be common to everyone.
the pressure got hold of me.
Yeah, true.
So, so, so should I try submitting it again? Because
Yeah,
the
just try
same.
it out.
Yeah.
Try submitting it out. It's fine.
Again, cross check. Not very sure. Yeah, it's the same.
Okay. It's fine if you get an error as well. Just try submitting it.
Okay. Again, I'm
Okay.
getting.
Now what's the thing?
Okay, yeah. I will put it as- plus 2 and plus 2. Seeing and answers. Yeah. Then- yeah. Then-
I think no one from the students as well is able to find out the mistake.
Yeah. That's- Okay. Setting into maximum of it. And then answer. I think this should work.
Okay, so what was the mistake?
Yeah. I have to iterate up to n plus 1. I iterated only up to n. That was
Okay.
mistake. And
Let's hope now. Okay, it goes a
Yeah.
bit.
Can't answer.
Yes. Does anyone have any queries in this problem? You can write it on chat or you can unmute yourselves. You all have the mic access. So now Ganesh can drink water peacefully.
Yes.
If you have any queries, guys, you can ask it out. Okay, I think there are no more doubts. Do you have something more, Ganesh, to share? This is it, right?
No. Yeah, that's it.
Okay, yeah.
Happiness of accepted.
Yeah, that's true. That's always there actually. Like irrespective of whatever problem it is and wherever you are. Okay, guys, thank you all. So we would probably end the session with this. It got extended by a bit, but I hope you guys enjoyed. So yeah. So yeah, bye bye, guys.